Welcome to the project demonstration of IoT Power Theft monitoring and alerting system using PIC microcontroller. So the main application of this project is we are making use of this PIC microcontroller to monitor the current transformers data continuously from these overhead lines. So as we know that in the street lines we are going to be transmitting the power from one substation to the total street levels, and these are the transmission lines and the street level transmission lines. And whenever the power theft occurred by tapping these in between the poles, so in between the poles, if anyone trying to access the power without getting the energy meter, means power tapping is done, the system will continuously monitor the current transformer status between the poles to this current transformers, and whenever the voltage difference, current difference is occurred with the help of these current transformers, means it will measure the current on these lines, and whenever it is more than normal values between the poles, so these are directly getting from the current transformers as energy meters directly, and this one is the tapping load. So when we place the tapping load, then the difference will be placed between these two current transformers. The voltage is converted into the DC voltage with the help of these potential divider circuits. As we know that current transformer will provide us the AC voltage, and that will be stepped down and regulate to the below 5 volts with the help of these potential divider circuits to provide that input to the PIC microcontroller pit A0, A1. So whenever the difference was increased than the threshold value, for example, so if the person consuming the around 200 watts load, so we will place that to 300 watts of limitation. So when it is more than that, it's assuming like the power theft occurred between the poles as it was more than the normal one. So that will be provide the buzzer alerts through this buzzer and visual alerts on the 16:2 LCD screen. And also continuously we are uploading the current sensor differentiation data to the Thingspeak with the help of this ESP8266 Wi-Fi module. So coming to the interfacing circuit connections, we have interfaced the pin number, this LCD display pin number B2 to B7, and buzzer at pin number C4, C6, C7 for this ESP8266 Wi-Fi module. So here we are providing mainly two power inputs. One is for these overhead lines, there's a transmission in the street levels, and this is the adapter for the power supply of this PIC microcontroller. So here while demonstration, when we provide the power supply to this, very safely check this, these are the directly 230 volts passing lines, so don't touch anywhere on this board. Okay, so before demonstration, first of all we need to on the hotspots, as through your hotspot only the system will upload the data to the Thingspeak. So configure the hotspot name to project 7052 without any space, there is a capital letter, password should be 1234567889, and AP band should be 2.4 gigahertz. After configure these settings properly on the data and hotspots, and log into the Thingspeak. So after login, we can see this one in my channel settings, and just go to this power theft. So these are the previously captured data. So before getting into the new data, we can download this, and means we can erase that. Before erasing that, should take this backup. So go to data import exports, and in that download the data. So after you successfully downloaded, the data will be open Excel sheet format, which will has the date and time and how many samples till now collected, along with the field data. So you can see this, the field data, date and time, and how many entries till now taken. So after you took up this backup, now go to channel settings. In that, do clear channel, don't delete that, only clear channel. After successfully clearing the channel, now go to private view. There you can see the old data got erased. Now on the power supply to this kit initially, so check twice before giving the power supply to the circuitry. So as you can see, the welcome message displayed on the LCD screen, and status is normal. So I'm disconnecting the tapping load, and just I'm connected on this one, and now on the power supply to this. Once you on the power supply, check safely mark. Right. If any junk data displayed on this one, just restart this. Right. Status normal. As of everything is normal, there is no tapping load connected. So check safely. Right, when it is attached, as we can see, the theft detected. And wait till the data will be uploaded to Thingspeak, as it will take around 12 to 13 seconds of duration. We can see the difference of theft current at so-called 5 amps. So for demonstration, we kept this is the limit. Till it is normal, the system keep on providing the audible alert through the buzzer. Right, if it is normal, again LCD normal and buzzer off. Right, so I am again explaining you, this is the lines which has the 230 volts directly. So very safely and check twice before connecting that. So if any junk data displayed on the LCD screen, just reset the system with the help of this reset switch. That's a reset switch. To reset the microcontroller, it only restart the microcontroller. Right, theft detected as a theft tapping load connected, and it is again normal. Okay, the humming sound will be coming out from this transformers, no need to worry about that. It's due to the eddy current loss between the primary and secondary coils. So you can see that, and it is normal, 0. Right, and again we can erase this by going to the channel settings, erase the channel, clear the channel, that is, and before erasing don't take the backup, as clear the channel and data import export. Thank you.